Hi everyone. In this module, we're going to continue our discussion of the quantitative side of lighting design, focusing on the point-by-point method, which is associated with accent lighting and task lighting. And as we work our way through this method of calculation, we're going to ask ourselves, how do we measure light levels? How to determine how much light we need in a space or on a particular surface? And then how do we design to achieve that particular light level? And we'll take into account some other factors when calculating and placing your lights in your room. So let's get started with that first question of how exactly do we measure light levels? And this week we're going to focus in on a unit of light called the candela. So luminous intensity or candle power is measured in candela, and it's defined as the intensity of light in a specific direction. So let's go back to our water analogy and see if we can understand this term. I've placed a picture of a fountain here. All right, you can imagine a luminaire spraying out light in all directions in this case. All right, I went ahead and flipped this over because typically our luminaires are on the ceiling. And you can see that the candela, all right, of that luminaire would be measured in a specific direction. So that would be the light that is being emitted, all right, in this one particular direction, or which might be different than the light that's being emitted in this other direction. So if candle power is the intensity of light in a specific direction, illuminance, let's remember that and reach back to this one, is the amount of light that falls on a specific surface. All right, so candle power in this example is the intensity of light in a particular direction. Illuminance is going to be the amount of light that's falling on that particular surface. Two lamps which emit the same amount of total lumens could have different candle power. And here's an example for you. On the left, we have a spotlight. Most of its light is being distributed all in one direction. It might have a higher candle power in that direction than a flood lamp, which is in general distributing its lumens more widely. Candle power and illuminance are both part of the photometric data of a specific luminaire. Ooh, what's that new vocabulary word? What are photometric data? They are the numeric information about a luminaire's performance that you might find on a spec sheet or a cut sheet. You're going to need this information in order to perform your lighting calculations and design for the appropriate amount of light. Your textbook has an example in this chapter, and you can see in figure 8.3 and 8.4 here your example luminaire and the photometric data that go along with it. Now, there's a couple of different ways that a manufacturer might choose to present its candle power data for a particular luminaire on the spec sheet. All right, so you might see a candle power distribution graph, a candle power summary, or a center beam candle power value, CBCP. All right, so the distribution graph is a visual way to show direction, pattern, intensity of light distribution. And a candle power summary is going to be a table of numeric values. This one's going to be slightly more accurate because you can directly look up a number and not just guess from a graph. All right. The center beam candle power is going to be a single value, one number, and that's going to be the candela in the direction pointing directly away from the luminaire, called that center beam. It assumes that a luminaire is aimed directly at your focal area of what you're trying to accent, right? And so this is fairly common kind of data for accent lamps. Let's take a look at how to read these different kinds of data. Starting with the candle power distribution graph on the left. Now remember, this is the example from your textbook, so you can go ahead and follow along with that. And you can see that this is a polar chart. All right, so we're assuming that the light source is right here at the center of this chart. Sometimes you'll see it as a whole circle. All right. Sometimes you'll see only half the circle, and we just assume that the other side is symmetrical with that because many light sources are symmetrical. All right. And so what you do is you would choose the angle, the vertical angle that you're interested in. Are you interested in where the light is directly pointed at? All right. That's the most common. And in that case, you would go directly down right there. Okay. Or are you interested at something that's set off at a different angle, maybe a 30-degree angle? That's the example in your textbook. In which case you would count up from the bottom. You go 10, 20, 30. Here's 30 degrees right there along this line. All right. And what we look for is where this contour crosses your angle line, and that's going to be right here. I'll set my mouse right there. All right. And so you would, at that point, know, okay, that your candela value is going to be somewhere between 1163 right here and 1550, and you'd be able to interpolate or guess that that's going to be about 1300 candela. When you're looking at the candle power summary, that's right here. This is a chart or a table, right? So it's going to have more specific numbers. And you're going to go ahead and read the vertical angle. 0 is going to be directly down, right? Or we might be interested in, as the example, 30 degrees from the vertical, right? And then you would read one of the numbers here. Well, which one? Oh, that's kind of confusing. It turns out, all right, that this particular luminaire has an across and an along values that are different. It's not symmetrical in three-dimensional space. All right, so we also have to choose a horizontal angle. All right, and if you go through and look at all these values, it turns out that that candle power distribution graph is done for the 90-degree angle, which is the most common. All right, so it's the across value. And so we would go ahead and read down and find that value right here. It's 1334. So you can see that we were roughly right. We guessed 1300. And we got a more exact number from the candle power summary chart, excuse me. All right, so the other thing you'll see that's even easier than those methods is the center beam candle power data. CBCP is what you might see, and this is an example here. It's a different luminaire. Okay, so those other ones are a separate luminaire. This is for a PAR 20 lamp specifically. All right, and here's the spec sheet for that lamp. And there's many different models of this particular lamp. And for each model, the manufacturer has given, way over here in this table, a CBCP value. This particular model lamp has a center beam candle power of 3000 candela. And you can just read just the one number. All right, everybody, in this video, we just covered some of the different types of photometric data. Specifically, we dug deeper in on candela, and then also how to find those candela values for a specific luminaire on their spec sheet or cut sheet. Thanks.